The assessment for day 15 is a bit of a capstone in that it pulls together a number of your skills and tries to give you an opportunity to solve an interesting problem. It's not one that can be solved by any of the immediate Python functions or statements. It requires you to apply some problem-solving skills, try to figure it out. The idea is to give a list of numbers and a specific target value and return an element in that list such that no other element is closer to the target than the one that's returned. It's a bit of a mouthful. Let me try to explain it. Let's say that your target value is 9 and you're given the numbers 7, 1, 12, and 15, and 5 as a set of values. I want to return an element such that no other element is closer to the target. Well, the number 9 doesn't appear in here, so I got to find an approximate match. 7, for example, is 2 away from 9. 1 is 8 away from 9, so 7 is closer. 12 is 3 away from 9, and that means 7 is still closer because he's only 2 away. 5 is 4 away from 9, and that ultimately leads me to believe that 7 is in fact the number which is closest to the target of these elements. If you reflect on the order of that process, the way I did that by hand, it should give you some insights into how to write a function to do the same. So this is a function called closest to target. I want to pass in my values. I'll do target and then values. Return the element and values that is closest to target. I guess such that no other element is closer. Now, we have to be, just to be fair, sometimes you might find there are two values that meet the same criterion. So if my target is 2, for example, my values contain the lists 1 and 3, well, both of them are 1 away, so I could return either one. And in fact, that still meets my specification. I want to return some element such that no other element is closer. So if I return 1 or if I return 3, either one is valid. Okay. Clearly I need to have some kind of loop. Well, let's start with a definite loop and try that one out. Also, let's say I've got something that's found, and I don't know what found is yet, so I'm going to call it none. When I'm done, I'm going to return found, and I want to do something for every element in the list. Now, what is it that I want to do? Well, I've got to find out the difference. What's the difference between the element that I'm currently looking at one at a time through the list and my target? That distance could be positive or negative, so I should at least make sure that I use positive to determine how far away I am. Now, you may have seen in some of my lectures the ability to use ABS, which is an absolute value function that's given to you in Python. Absolute value of a number that's positive will be that same number, but if you pass in a negative number, it will return the absolute value of that. So I don't just want the difference as element minus target. I'm going to say the absolute value. This will at least give me that positive number. Now, I have to keep track of my best estimate. It's not an estimate, actually. My best computed one. And so we'll start with the idea that says, well, if it turns out that I haven't found anything yet, found is none, then I'll just assume that my element, the one that I'm looking for, is indeed that element. Just because I have nothing else to go on, that's my best guess. However, what if it turns out that the new element I'm looking at is actually closer to target than found? Well, one way I can deal with that is by saying, well, if the difference that I'm looking at is smaller than the absolute value of the difference of found my target, then I have a new closest element. And I will then reflect that by saying found is going to be that element. This is pulling together a lot of stuff. And let's just save it to see if it works before we go on with our pronouncements. We run this. try my two little examples. What's the closest element to target if I pass a 9 and the list 7, 1, 12, and 5? Well, it says 7, which we just worked on was actually the right one. How about closest to target of 2 when I got the list 1 and 3? I mean, it could be either one, as we talked about. What if the value we're looking for is actually in the list? So I'm looking for 5 and got a bunch of numbers here. Well, it finds 5. So it looks like I've got the code right. Now let me go back and just make sure we understand how it works. We did it by hand to get a sense that we needed to do a for loop. We then reflected on it and said, well, I start with the first one and I say, well, maybe he's the closest. And then I continue on for the rest and make a decision. So I can do that a number of ways. Here's one. I'll assume that I haven't found it yet. And then as long as I have a bunch of values, I will do my check, which is if the difference of the element I'm looking for from the target is actually smaller than what I currently believe is the smallest one, then I found a new closest element, and I return it. The way I've structured it this way also has this nice added benefit that if you're looking for a value in an empty list, well, you're not going to get anything back because there is no value closer to target. So that's actually a nice little feature, this use of none. But I want to make sure that you at least see another way of doing the exact same problem. So let's do it using range when we are looking at index values. And to sort of set this up, let's imagine we'll do this one with none, and I'll do this one here closest to target. What I can do is I can assume that the first element in the list is the closest, and I will wait to be proven wrong as I go along my list. So in this case, I'll say, well, let me assume that my found is values 0. Let me assume that's the best one, and I'll return it. However, it might be the case that I have to look at the other elements, and I'm going to do this by starting at this range function you've seen before, but I'm going to skip the 0th one because I know that I don't need to look at that again. I just need to look at the first and onward. And so if it turns out that the absolute value of the difference of the ith element minus the target is actually smaller than the absolute value of what I believe to be the best one minus the target, then I have found a new one. So found is going to be values of I. This looks a little smaller. It does it all in one statement because I assume I found it and then I try out to see if anyone else can step forward and be the smallest one. Let's look at this and try some of the ones that I've done before. It finds 5 in that list. Either of those works, and even finds 7 there. Now the one thing that this doesn't do well on is what if you pass it in an empty list? You're going to get it indexed out of range. So you'd have to make a small little change, and it's easy to do. If the len of values is equal to 0, then return none, because there is no smallest one. So this is a assessment that gives you two different solutions. One that uses indexing by assuming that the first element in the list is in fact the closest one, and then waiting to see if another one comes forward to be the smallest. Or another one that just goes through each one and assume I haven't found it yet, and go through the loop the first time through the loop. I set my found to be that first element, and then each subsequent time through, I check to see if I found a closer one. They both do the job, and I want you to at least look at both of these to make sure you understand this particular assessment. So this concludes a rather interesting and challenging capstone assessment for Day 15.